I'm going to give you a little help on 3 of them from your note packet. So the first one will be number 3, where you're given a function g, it's explicitly defined, and you're asked to find the derivative of the inverse function at x equals 1. So what I know is that 1 comma something is on the inverse function. It has to be. It says at x equals 1. What that also tells me is that something comma 1 is on g. As I stated in your notes, this is usually easy to find. It's either handed to you, you get it off of a table, or on one like this, you have to go back to the function and ask yourself what x value gets mapped to 1. And it'll be a very easy, it's either, when they give you the model like this, you can only really do it with trial and error. If it doesn't factor, you don't have Calc 0, a calculator, or something like that. So usually try zeros and ones. This one's obviously 0. When I put a 0 in for x, a 1 comes out. I can just see it. So they'll always be quite easy to find. What that gives me is my corresponding points. The next thing is I don't have the inverse function. It'd be very ugly to find it, swapping out the x's and the y's and then trying to solve it for y. Good luck with that. But I can find the derivative of g. I can find g prime of 0 with the information given. So I will hop on the curve g and find its derivative at 0. G's derivative is given by 10x to the 4th plus 3x squared. So anywhere along the g curve, its derivative can be found by that model. I'm supposed to do that at 0. G prime of 0 is 0. What does that mean? If a function's derivative is 0, it means the slope of its tangent line is 0, which means at that spot I have a horizontal tangent line. And so normally I would do a reciprocal to determine what the derivative of the inverse function is at its corresponding point, but the reciprocal of 0 is undefined. But that leads me to the fact that if this has a horizontal tangent line, then the inverse function will have a vertical tangent line, which is undefined. So I can say that the derivative of g inverse of x at 1 is undefined. So that one was kind of weird because you had to, first of all, work with an explicit model and then interpret what does this mean and how do I do the reciprocal. And again, if your derivative is 0, it means there's 0. Change in y is 0. Change in x we don't know. But when we swap those out, we'll get a 0 in a denominator, which leads us to an undefined slope. The next one is tabular. It's number 6. I've got to see what we're supposed to find on number 6. So let me find a worksheet. I drew the table, but I didn't put the directive on there. So let's see. Number 6 is, and I think I'll just do part A. Leave part B up to you. So part A is to take g's inverse and find its derivative at 1. So again, let's start this. What I know is that 1 comma something is on g inverse. It has to be. How can I find the derivative there if it's not on there? Which also tells me that something comma 1 is on g. I'll consult my table and see what gets sent to 1 on g. Here it is. The y value is 1 when the x value is -1. So -1 gets sent to 1, which means this goes here. And again, I'm looking for the derivative of g inverse. And again, g inverse isn't even on here, which means I'm going to have to use g to get it. I can get g prime at -1. I'm hopping on the original function, and I'm going to find its derivative at -1. I'll use my table. At -1, the derivative is -1/5. On the inverse function, the derivative, so on the inverse function, the derivative at the corresponding point is the reciprocal. So my answer is -5. Notice the process was identical to number 3. It's just I was given a different situation. I didn't explicitly know what G was. I was given a table for G. And the last one, because something weird, the whole notational fluency is huge with this number 8. I'm going to write this a little smaller so I have a little bit more room to write. So for number 8, we have a function h explicitly given as the cosine of x plus 3x. What am I being asked to find? I'm being asked to find the derivative of h inverse at h of 0. So this is a little different, but again, interpreting what they're asking me to find will get me started. I need to know where am I finding the derivative? And it's at h of 0. Well, I can find that. I don't get it off a table. I have to explicitly go put it in here. They didn't hand it to me, but I certainly know what cosine 0 is. It's 1. So really what I'm looking for is the derivative of the inverse function at 1. So now let's begin with our normal model. I have no idea what h inverse is. I was given a model for h. So what I will do is try to get myself onto the curve of h. How do I do that? I start with the inverse function. And I say 1 comma something is on h inverse. It has to be if I'm to find the derivative there, which means something comma 1 is on my original curve. Let's go back up to my original curve, and I'd say what would cause a 1 to come out of this? And I already figured it out that it was a 0. I already know that when I put a 0, my output or my y value would be 1. So I know there's a 0 here and a 0 here. My goal again is to figure out the derivative of the inverse function right here, but I don't have the inverse function. So I will find the derivative on my original curve, h. That I can do. H prime at any point along the curve is negative sine x plus 3. In particular, at 0, trying to put a smiley face in there, the derivative would be negative sine 0 plus 3, which is 3. So I'm on my original curve, and the slope of the tangent line there is 3. What do I want to know, though? I want to know the slope of the tangent line of the inverse function at its corresponding value. It's 1/3. Notice again the process on all of these did not change. I need to get on the inverse function without necessarily knowing what the inverse function is. Could I find the inverse function of this and actually explicitly write it? That'd be pretty difficult. Try it. You'd have y equals cosine x plus 3x. You'd swap this out and get x equals cosine y plus 3y. Now solve that for y. You have incompatible functions here, and it's just not going to work. So I didn't really need to know a model for the inverse. What I did was I made sure I was able to hop onto the original function, find the derivative there, either by table, by pre-measured bowls, or by taking a derivative. It depends on the information that you're given. Once I found the derivative there, I know that on my inverse function, at the corresponding points, 1, 0, 0, 1, the derivative is the reciprocal. That's it. Hope that was helpful. If not, I'm trying.